In this episode, let's work on the terrain destruction. Actually, it's not very obvious in the final effect, since it'll be covered by smoke somewhat. Therefore, I won't go hard at it. When dealing with a project, we'd better have a clear picture of the priority in our mind. For the main elements, spend more time tackling it. But for the secondary elements like this, a rough effect is fine. Alright, let's get going. I've imported a high-res terrain. If we break it directly, the efficiency will be very low. Also, it's really unnecessary. So we reduce the resolution and convert it to polygon for a faster simulation. As for the lost details, we can use the normal map that we made before to get them back somewhat. This process only involves the crater, so we clip it out. Drop a height field clip node. Raise min clip a bit more. Okay, well, we need the upper part. Let's adjust the min clip. Here a mask is created. See? We can drop a blast node and delete the part whose mask attribute is greater than 0.9. The mask attribute runs over the point class, so select points here. Make a copy of these nodes and keep the lower part. There is a small gap. We can raise the max clip of the lower part a little bit to overlap the upper part slightly. Now the gap is fixed. There is an opening at the bottom. We need to close it before destruction. Drop an extrude volume node. Wire it up. Select smooth shaded here. Let's see if everything goes well. If observing carefully, we'll find there is a seam. Disable this blast node, we can see the seam becomes very obvious. Actually, after we apply the extrude volume node, the normals at the edge are changed. The same thing is true with the lower part. To solve this problem, we can apply the normals of the intact terrain. There is a sharp edge here. We raise the cusp angle, now fixed. Before the blast node, we drop an attribute copy node. Copy the normal attribute to the upper part. Okay. Duplicate this node to the lower part. Give it to the extruded upper part too. Okay, solved. Next, let's break the crater. Drop a Voronoi fracture node and an ISO offset node to transform the polygon to a volume. Scatter points. Drop an exploded view node to blow it up. The edges of the pieces are straight and without any variations. If all the pieces end up like this, the result won't be good. To solve it, we can use Voronoi fracture to shatter the model, then apply noise to the interior faces, and then shader the intact crater with the interior faces. This way there will be rich details on the interior faces. Alright, let me show you how. The crater model is of high resolution, thus the solution will be a bit slow. So we can drop a bound node to get its bounding box and fracture it first and isolate the interior faces. We can use them to shatter the model later. This way it'll be much faster. See, it's refreshed instantly. Let's try fracturing the crater model directly. Obviously very slow. It took almost 20 seconds or so. Reduce the fragments count and drop a blast node to delete the outer faces. There are many overlapping faces here. Let's handle them. Drop a clean node. Toggle on the fixed overlaps and the consolidated points. Only a part of them is deleted. Dive into this node. In essence, it consolidates points with a fuse node, yet the distance of the fuse node is not big enough for this large scene. Here we can directly drop a fuse node to increase the snap distance here. Now the overlapping faces disappear. Toggle off the delete overlap pairs. Okay, drop a rematch node. One thing to keep in mind is that when we drop some nodes like VDB from Polygon, rematch to simple model, we'd better not wire them up immediately since their default values may cause computer freezing. So remember to raise the target size first and then wire it up. Now we can reduce it gradually to figure out a proper value, then drop down a mountain node to display the interior faces. The element size and height also need to be set larger to match this large scene. Increase the roughness for more details. Yet it didn't work out as we expected because the resolution is below. Back to the rematch node here and reduce the target size a bit more to support more details of roughness. Okay. Drop a Boolean node. The left input is volume and the right input is a surface. So here select surface and here select shader. Add an assemble node and apply an exploded view to check the fracture. Now we can see there are some variations at the edges and interior faces. Let's take a look at the previous pieces. So this is a great way to control the fragments. Okay, let's build a general process of fracture. Toggle on the create a packed geometry, drop down a dot and get into it. I prefer model solver here because the forces added later can also work on the fragments. Yet the Boolean solver cannot do the job. Disable this pop drag force for the moment. Here we select first context geometry and reduce the number of substeps. It's totally fine since the fracture is not the focal part. Also, we can save lots of solution time. Next, let's drop a terrain object. The DOP network supports the height field terrain. We import the lower part of the terrain. Paste this path. Toggle on use height field. Solve it. The terrain response varies slightly though. Raise the gravity. Okay, let's set the output. Drop a DOP import node and drop the DOP node here. Copy the name of this node and paste it here. Select create points to represent objects. Then add a transform pieces node. Here, the orient and the pivot attributes are available. That's why we can use this node to drive the static fragments. I'll handle it later. There are some useless attributes. Let's get rid of them. Drop down an attribute delete node. Just keep velocity, name, orient, and pivot. The last three attributes will be used by this node. V is commonly used, so keep it, just in case. Okay, add a file cache node. After setting it, we can click Save as Permanent Defaults. When we create a new file cache node, these settings will become the default values. Hold Shift plus S, switch to the rounded style. This is what I like. Alright, these fragments are still kind of large. Let's fracture the crater again. Come up here. There is a large plume of smoke, and the terrain there will be covered completely, so I won't work on that part, but mainly fracture the front part. Drop down a Draw Curve node. Wire it up. Set the projection to geometry. The frame lines disturb our view, so toggle off Show Guide Geometry. Display this node. Hit Enter in the viewport. Now the lines we draw can be projected onto the terrain. Okay, let's first draw some lines. As long as the lines are distributed evenly, it's perfectly fine. Draw some lines inside as well. Okay, I'm done. Then drop down a scatter node and scatter some points. Currently, they're on the lines. We add a point jitter node and set a large scale to let them get into the inside of the terrain. It's unnecessary to keep relaxed iterations on. Merge this scatter with the previous one. We can see there are many points outside the terrain. Because we scatter the points in the volume of the bound, it is totally a waste. We can scatter points in the volume of the terrain. Let's check it out. Display the Boolean node. Let's see if there's any problem. The bottom is not completely broken. Let's figure it out. Display the mountain node. Well, this model is not big enough, so simply scale it up a bit. The viewport field to be refreshed. We can disable this node and enable it again. Okay, let's see how it goes. Okay, fixed. Let's take a look at the pieces. Seems still a little large. Increase the point count. Okay, we can proceed to change it if the fracture doesn't end up well. Let's move on. Toggle on this checkbox and check if there are any overlapping faces. Indeed, there are. We raise the snap distance a bit. Well, remember to uncheck this parameter. There are already 53,000 pieces. If we solve dynamics based on this, definitely it'll take time. So before that, we can do some optimization. Given that the terrain explosion will be covered by smoke somewhat, we can optimize the pieces as much as possible. Those inside fragments of the terrain can be removed. Come to the Boolean here. We output two groups, group outside and group inside. Drop down a color node and assign different colors for them. Set the class here to primitive. This way the inside won't be reviewed. The inside is in a dark color and the outside in a light color. Okay, everything goes well. Next, we add an attribute create node and create an attribute for the outside. Here, for the points in the outside group, the keep attribute is 1 or else is 0. Okay, let's transfer this attribute from point to primitive according to connectivity. Drop a connectivity node. Here, a class attribute is created, set it in primitive. Then drop an attribute promote node. Select primitive here. Set the piece attribute, type in class. Okay, done. Apply maximum here. Then add a blast node and delete the pieces with a keep attribute smaller than 1. Select primitive. Let's check it. Cool, there are only the outer pieces. Okay, let's solve it and see how it goes. We can see the upper pieces basically keep static, but those at the bottom fall down. To fix this problem, we can set them to passive objects. Get into the DOP network. Toggle on this checkbox. The active attribute controls whether an object is active or passive. Back to SUP. The lower part of the terrain is pretty close to these pieces at the bottom. So we can create an attribute for the lower part of the terrain, then transfer it to those pieces of the upper part at the bottom. Okay, duplicate these two nodes. When clipping the terrain, we set a slightly high height for the lower part of the terrain. To avoid something wrong, we can apply the same clip height for the lower part and the upper part. Actually, there is still a bit of intersection, but we just go ahead. If the attribute transfer goes wrong later, we can change it then. Okay, drop an attribute create node. And set the name to active. Keep its value 0. And we add the active attribute to the pieces and set the value to 1. 1 indicates active, 0 indicates passive. Then drop down an attribute transfer node and select active here. Add a color node to visualize the result. Select ramp from attribute and select active here. Okay, it works. We can see the attribute transfer goes wrong at the bottom. Perhaps the upper part and the lower part don't fit perfectly. We can either change the distance threshold or change the soft clip scale. Okay, set the soft clip scale of these 3 nodes to 0. Fixed. Alright, let's move on. Again, we transfer the active attribute to primitive. Then transfer it back to points. The class attribute is not needed anymore. Reset the promotion method. Jump to this node. We set it to minimum. Now the active values of the pieces at the bottom become 0. The distance threshold is a bit large. Let's reduce it. Connect this node to the assemble. After objects being packed, the active attribute failed to be inherited automatically. We need to transfer it again. Okay, let me organize the nodes a bit. Next, let's add constraints. Unpack it first. I'll catch the packed objects out since it doesn't occupy too much disk space. Let's add constraints. Display points. By default, the constraints are added between points. This is exactly what I want. Then we add the RBD constraint properties node to set the constraint type. Select soft here. Keep the position and the rotation. As for the stiffness, we leave it as it is for now. Okay, let's import the constraints to DOP. Drop a Boolean soft constraint relationship node. Select second constraint geometry. Well, the guys are in the way of my view. We hide them. Usually the rest length is set to 0 when we apply the soft constraint. Let's check it out. Okay, the terrain doesn't respond even at the 30th frame, which proves the constraints work. Alright, let's add force fields. Here is the intact terrain. First, we extract the inside faces of the crater. You can also use a blast node. Here, I share another method. Create a point with an add node. Enable the snapping mode. We add this point to a group and drop a group transfer node. Remember to set the group type to point, then select the group. While the distance threshold is not visualized, we can add a blast node and toggle on this. Okay, adjust it again. A small size is fine. Then scatter some points on it. And drop a copy node to get more points so that the force can cover a larger range. Display the terrain. Okay. Next, add a VOP node. Make a copy of this point and wire it up to VOP. Get into it. Okay, let's sample the position of this point. Drop down a near point. Wire it up to input 2. Add an import point node. Also select the second input. Then subtract the positions from the original positions and output the result to V. Display bell and hide the terrain. Now we get a force from the center to the edges. Let's normalize it to make the force uniform. Now the strength becomes 1. So we first bring the strength back. Then add a noise to disturb it a bit. You may want to ask why we normalize the force to make it uniform and then disturb it with noise. Actually, this variation is not what we want and is not controllable, but the force is easy to control with turbo noise. Select 3D noise, original Purdy noise. It doesn't matter, just as per your preference. Let's increase the amplitude. It's too fragmented. We lower the frequency a bit until we see such large variations. Okay, reduce the amplitude a bit. We can also adjust the offset to find a satisfying result. Okay, we import it into DOP and see how it comes out. Add a pop-up node. Select the third input. Now the input 1 here reads the input of port 3. Okay, drop a point cloud open node and a point cloud filter node to read V attribute. The search radius is not big enough for this large scene. Let's raise it. Then we add an add node. Add this velocity and the original velocity. Output the result to the final velocity. Return the gravity to the default value. Let's check it out. Well, there's no response. Actually, there are a couple of reasons. The force is a bit too small or the constraint is too strong. Let's first lower the stiffness. By the way, we didn't set a condition to break the constraints. Let's get to it. Add a sub-server node. Let the constraints break when the angle is greater than 0.2. Okay, let's check it out. It responds slightly. Lower the stiffness a bit more. And reduce the angle. Is a bit large. Now it works. The pieces here are in small mass, so they are easy to fall apart. But for the pieces here, they're different from the small ones since they're large. Okay, let's sketch it out. We can see the force is too strong now. All the pieces are blown up too much. As we all know, the force that drives an explosion usually lasts just a few frames. So let's fix it first. Add an enable solver and make the force only last 4 frames. Let's test it out. Well, the terrain doesn't respond too much. Let's double the force. Okay, let's make a preview. Now the force field and the constraints match well. Some pieces fall apart properly, and some are fixed by the constraints. Besides, the force is strong here, weak here, and strong here. I like this variation. It just looks a bit symmetrical and dull. I'll handle it a bit later. Now let's focus on another issue. The current dynamics look like there is no drag and gravity. Actually, we added gravity, but it's too small for such a large scene. Here we can increase the gravity and add a drag force. Besides, some fragments are a bit too large. One thing to keep in mind is to shatter the terrain well before the dynamics simulation. Otherwise, we have to rework the dynamics simulation. I think some fragments are still a bit large, like this one, and this one. By the way, it's not that the constraints in them are not broken. but indeed they are too large. Okay, let's shadow them again. Duplicate these nodes and draw some more lines. Let's check how it comes out. Well, still a bit large, I think. Double the point. Okay, let's see if there are overlapping faces. I deleted the fuse here and directly adjust the distance here. Check delete overlap pairs. Some pairs left. Increase the distance a bit more to fuse them. Still a few, but I think it's fine. I forgot to uncheck it. Now the size of the fragments is good. It's a bit stuck now. Let's cache out the shattered pieces. One frame is enough. Bring up the gravity. Let's increase it by 10 times. Enable this drag force. A little bit will do. Let's check it out. It's too strong now. Bring it down. Great. Let's take a look at the preview. The dynamics look proper, so do the fragments. Yeah, the force doesn't seem to be enough. I'm not going to strengthen the overall force. Considering this area is the focal point, I'd like to bring up the force here and weaken it here. Okay, let's get to it. We can multiply the current force by a noise. We only want to control the intensity, but not vary the direction, so 1D noise will be fine. To avoid negative values, I choose the default one, which ranges from 0 to 0.5. You can check the doc to learn more about the range of per noise if interested. I won't go into details here. Display the velocity lines. Let's adjust the noise to get an intended look. Raise the amplitude and reduce the frequency until we can see large variations at the silhouette. Okay, reduce it a little more. Let's get into the camera and take a look. Adjust the offset value. Now it looks good. The force is strong here and weak here. Increase the roughness to get a bit of details. We can shorten the velocity lines for a better view. Besides, I want the force here to spew upwards rather than just to this side. Okay, drop an add node and put it here. Add a velocity attribute to it. Apply it. Read the attribute from the port 3. Change the attribute here to V. We add it after the normalized node. Select the third input. The near point node finds the nearest point, and there is only one point available, so we get this outward force. Okay, we create another point and move it over there. For the sake of view, we can set a large radius of points. Okay. Now we can move this point to adjust the range of the influence. Let's check it. Well, the force gets too strong. Before we revise it, let's lengthen the velocity lines. I'd like to create a flow attribute, call it force. Import it into Bob. Change this to force. Multiply it by the final force field. Bring it up around half string. Well, the force here doesn't work. We duplicate the attribute create node and give it to this add node. Delete the velocity and only keep the force attribute. No need to reduce the force here too much. A little bit will be fine. Is too uniform here. I want to keep the force here and weaken it here. Okay, duplicate these two nodes. Move this add node down a bit. Okay. Let's cache it again. The right one is the latest cache. The strength of the force is much smaller, but still a bit large. I'm not going to reduce it again. Instead, I'm gonna try a larger drag force. I'll make it weaker at the beginning and then stronger gradually so that we can get more explosive dynamics. Besides, there is another problem. The fragments rotate very fast and they don't look very weighty. So I'd like to add a drag force to control the rotation. Okay, let's first change the drag. Before the 25th frame, set a small value, even smaller than the one we just set. Until the 70th frame, the drag force grows to be a large one. The transition lasts 1 minute. Okay, let's add a pop drag spin node, which only works on the rotation. Let's try the settings of this drag. Cache it out and see how it goes. Okay, done. The right one is the result. It seems that the drag doesn't work. We brought up the drag force in the latter part, reduced it at the beginning. Yet the eruption is still that large. Besides, the drag force spin is a bit small. Obviously, the problem is not fixed. In order to limit the distance of the eruption, I'll show you another way to deal with it. But before that, let's first increase the spin resistance. Okay, let's get to it. Add a pop speed limit. Put these drag forces after the pop web 1. Toggle on the maximum speed. Let's try 1000. I just cached 84 frames. Take a look. Indeed, the speed is limited. Display the pieces. At the same time, the gravity can also be reduced slightly. Okay, let's check it out. Alright, the distance of the eruption looks good overall, so does the rotation limit. As for a few fragments with high rotation speed, I won't deal with them since they don't matter. Okay, that's all for the dynamics simulation. Next, let's set up the rendering. First of all, we need to import each part of the models separately. Add a file cache. Load the fractured upper part of the terrain. Import the lower part. Unpack the upper part. Split the active fragments from the passive ones. And merge the passive ones with the lower part. Then add a rest attribute to the active ones when they're static. We won't render this effect in this project, so cache it out. All the primitive attributes are not needed anymore. The detail attribute is not needed either. As for the point attributes, only keep the rest. Remove UV for now, since we'll do some processing later. Okay, let's deal with the terrain here. Actually, there are many primitives beyond the camera view, so we can optimize them out. So here I use this node. Generate a volume based on the camera view. Change the value here to 1. Display the terrain. Let's adjust the volume. Raise the Z-far and the uniform sampling divs. Drop a group node. Select the bounding volume. Increase the ISO surface. Check invert here. The range is dynamic all the time, yet we need to add up the range every frame. Drop a solver. We place the group node here. Set the display flag on the solver. Okay, we drop a group node to visualize the result. Select points. Well, it doesn't seem to work. We change the group mode to union with existing so that the selected points can be added up frame by frame. Drop a time shift node and freeze it to the last frame. Add a blast node. Well, the viewport is not refreshed. Alright, invert it. Merge them. This group is not needed anymore. Remove it. Then we add an attribute delete node. Get rid of all the attributes except the ones over the vertex. Add a clip node to delete this part. One frame is fine. Add the rest attribute to this static part too. Besides, the trees on the terrain also need to be animated with the terrain. Add a file node and import the points of the trees. First, we add a group transfer to split the points to be animated from the static ones. Create a group for the active pieces of the terrain. Okay, let's check it. Nice. Then use the transform piece to drive the trees to be animated. It requires a name attribute. We need to transfer the name attribute from the terrain. Well, there's no name because it's stored on a primitive class. Let's transform its class. Wire it up and take a look. There we go. There may be a problem. We can see there are some very small fragments. If the name attribute of the small pieces is transferred, the corresponding trees will be very active and look abnormal. So we can remove the small fragments. Calculate the area of the fragments first based on the name attribute. Add the blast node. Delete the fragments less than 100. Here we use the name attribute on the primitive class. So we do this before the attribute promote. Okay. Also, we need to cache it out. The animated trees and the static trees. Make a copy of the clip note to remove the trees here. Alright, let's cache them out. Okay, let's check the UV. Come up to the Boolean here. Drop a UV quick shade. We can see the UV goes wrong because the mountain doesn't have a UV attribute. Let's add a UV project to it to calculate UV. Click Initialize. There we go. The outer part is fine now. Let's check the interfaces. We add a name attribute temporarily. Okay, everything goes well. This UV is stored on the vertex. The original one is on the point. But when we cache it out, the one on the vertex will remain. Cache this node. Remember to hit this button to reload data. Okay, there is the UV attribute. Pay attention to the nodes that are to delete attributes. Maintain the UV attribute. Let's check again. Good. It seems normal, but when we check the attributes here, we will find the UV is not transferred correctly. This UV is fake. Let's invert the merge. Now there we go. Actually, it's because the UV attribute is different between the two inputs. Besides, we can also transfer the UV onto the vertex class. Okay. Next, we add a group node. Name it outside. Alright, let's cache them out. Next, we import each cache into a geo. Okay, let's assign the materials. It needs two materials, one for the inside faces, the other for the outside faces. We directly specify the material of the mountain to the outside and create a new material for the inside. Add a null node, set a render flag on it, copy these two nodes, and paste it here. Okay, let's move on to the trees. We just need to assign the material. I have added the terrain into Mantra. Let's adjust the inner material. Copy these nodes. Let's take a look. Well, the lower part fails to apply the material because I didn't set a group type to primitive. Okay, recache it. Let's check it out. Then the inner material. Create a constant node. Let's call it color. Pick a solid color. The inner faces are generally wetter than the outside. Let's dim it. Fine. Let's add some details to the inner faces, but it's not necessary to go hard at it. Connect it to normal. Raise the frequency. The amplitude is too high, reduce it. The render view is not refreshed automatically. Remember to hit the render button if re-rendering is needed. Let's apply another noise type. The noise size can be a bit smaller. Then use this term noise to revise the color of the interior faces. Add a color correction. Connect the term noise to gamma. Set another noise type. Add a phase range node. Restrict the mean gamma to 1. Okay, now there are some bright areas. It looks a bit richer. Increase the frequency slightly. Alright, that's all for the terrain destruction.